This video is going to show you how to add fractions with unlike denominators. This is made for the mathas questions that ask you the different steps in how you're adding your fractions and how you're breaking the denominator into prime factorization pieces. I'm going to be using the example fractions of 5/12 plus 7/20, and you can see over on the left hand side I went ahead and numbered each step just so that on future slides you don't get confused with which step I'm on. So the first step is that I need to factor the denominators using prime numbers only. I'm going to go ahead and write in the numerators just because those aren't going to change for the purposes of what you need to enter in for your answer. But then I need to do the prime factorization of both of the denominators, which I have 12 on the left and 20 on the right. The prime factorization is asking you to break down this number 12 into just prime factors, very simply. So I know that 4 times 3 gives me 12. 3 is a prime number, but 4 is not. So I need to break down 4 into 2 times 2. So I know that my prime factorization for 12 is going to be 2 times 2 times 3. Then I'm going to do the same for 20. So 20 can be broken down into 4 times 5. 5 is a prime number. 4 can be broken down into 2 times 2. So my prime factorization for 20 is going to be 2 times 2 times 5. So the next step I need to do is to write equivalent fractions with the LCD, meaning the least common denominator, but I'm using prime numbers only still. So in the last step I went ahead and factored each of the denominators, so you can see those there. The next step is I need to decide how to make these equivalent fractions and how to find the least common denominator. Here's how I explain the least common denominator. I want you to pretend that both of these fractions are two brothers, and brothers like to have the same things. You know what happens if you give a candy bar to one brother and the other brother doesn't get it? There will be a huge issue. So we want to be fair. Think fair when we're doing this. So I look at this brother on the left and I see, okay, he has 2 2s. Okay, perfect. I'm going to look at the guy on the right. He also has 2 2s. Okay, so far so good. We're both fair. Then I look at the brother on the left and he has a 3. Brother on the right does not have a 3. Well, that's going to be a problem. So we need to give him a factor of 3. Now, notice that we are not adding this 3. We're multiplying on a factor of 3. But I'm not allowed to just multiply the denominator by 3 and not multiply the numerator by 3. So you might have heard this explained as whatever you do to the bottom, you do to the top. The reason this works, that whatever you do to the bottom, you do to the top, is because 3 divided by 3 is 1. And so really we're only multiplying it by 1. We are not changing the fraction at all. Okay. So now I see that this brother on the right has a 2, 2, and a 3, but I also notice that he has a 5. Okay, the brother over here on the left, ooh, he does not have a 5. So again, I need to introduce in a factor of 5. So I'm going to multiply by 5. Again, whatever I do to the bottom, I have to do to the top because 5 divided by 5 is 1. I'm not changing it any. So then to write my answer up here, let me change colors here. To write my answer, I'm going to still have my same things on the bottom. So 2 times 2 times 3 times 5. And then this brother has 2 times 2 times 5 times 3. Now we know that just because the brother on the left has 3 times 5 and the brother on the right has 5 times 3, that doesn't matter because 3 times 5 is the same as 5 times 3. So we know that we have equivalent denominators. Then I am going to put my numerators on top. So now I have 5 times 5 on this side, and I have 7 times 3 on this side. My next step is to simplify the numerators, but again, I'm leaving the denominators in factored form. So 5 times 5 I know is 25, that's going to go there, and 7 times 3 is 21. Step 4 is to combine the numerators, so 25 plus 21 gives me 46. Step 5 says that I need to factor the numerator and denominator but use prime numbers only. Well, again, my denominator is already done. Just copy and paste that from your previous steps. But now I need to factor the numerator. So, 46. I see that it ends in an even number, so let me try 2 and see if I can break that down. 2 goes into 4 2 times, and 2 goes into 6 3 times, so I know that 2 times 23 works. You can also think of this as 2 into 40 plus 2 into 6. So 2 into 40, I know that 40 can be divided by 2 by 20, and 6 can be divided by 2 and get 3, and 20 plus 3 also gives me 23. That's kind of a unique way to think of it there. So I know that 2 is prime, 23 is also prime, so now I am going to put these up in the numerator here, so 2 times 23. My last step is that I need to simplify my answer. So what do we mean by this? You might have heard this in classes past called canceling. We're not really canceling. What we're trying to do is find 2 of the same numbers that can be divided to get 1. So in other words, 2 divided by 2 I know gives me 1s. Well, that's really nice because 1 times 23 is still going to be 23, and this 1 down here doesn't affect my denominator as well. So 1 times 2 is 2, 2 times 3 is 6, 6 times 5 gives me 30. So my final answer is going to be entered as 23/30ths.